We will be talking in this video about what's called the Fundamental Theorem of Arithmetic. Because this is the first video in this series, first of all, what's arithmetic? Pretty much whenever you have a problem talking about natural numbers or integer numbers, you are talking arithmetic. If your problem involves decimal numbers, pretty much you are talking algebra. Alright? So, you can see kids beginning from pretty much grade 2 on doing something like this, at least in North America. For example, let's say they write an 18 and they draw this vertical line to the left of it, and then they say, okay, 2 divides 18, so 2, they write 2 here, 18 divided by 2 is 9, and then they figure out, oh, 3 divides 9, so they write a 3 here, 9 divided by 3 is 3, and then 3 divides 3, and they write a 3 here, and then 3 divided by 3 is 1, and as soon as they get the 1 on here, they put it in a box and they stop, and then at the end they say, oh, 18 is equal to 2 times 3 times 3, or is equal to 2 times 3 to the power of 2. Alright, so that's what they do in early grades in school, and maybe they don't know it by name, but what they actually do is they apply what's called the Fundamental Theorem of Arithmetic to decompose, in this case 18, in product of prime numbers. Okay, now just to fully state the theorem, it pretty much says if n is a natural number, then there are prime numbers p1, p2 all the way up to pk, and non-zero natural numbers alpha 1, alpha 2 up to alpha k, such that n is equal to the product of p1 to the power of alpha 1 times p2 to the power of alpha 2 times all the way up to pk to the power of alpha k. Alright, so, and this is called the prime factor decomposition of the number n. Right, so again, the p's are prime numbers, alphas are exponents that are not zero. Okay, and more than that, the Fundamental Theorem of Arithmetic says that the numbers p1, p2, pk are uniquely determined up to a permutation, meaning that two prime factor decompositions of the same number differ by a permutation of the prime factors, but there cannot be the case that the two sets of prime factors involved in two prime factor decompositions of a given number are different from each other. And the powers alpha 1, alpha 2 up to alpha k are uniquely determined. So this is pretty much what we need to know for now about the Fundamental Theorem of Arithmetic.